Alright guys, so in this video I'm going to go over the order of operation of things. So what I'm going to do is I'm going to show you how this stuff is actually executed in the background. So I'm going to use Unreal Insights. If you look down here, you'll see a trace button, and if you press it, it'll open up a bunch of stuff. For a lot of you, this is going to feel overwhelming. You can start the trace here, or you can press that button there. This will be unchecked on your end, but if you check Open Insights after trace, it'll automatically launch it for you and show you the thing that you just traced. And then a trace is basically just a recording of everything that's happening, the stuff that's being processed by your processor and GPU. And your channels determines what is being recorded, basically. So the act of recording this stuff does have a performance cost, which is why normally you want to, if you're testing raw performance of your game, you want to test it outside of the editor, because the editor does stuff like this right here, like for debugging purposes, and some of that stuff can have a serious impact on performance. So anyway, let me just show you here. You can launch Unreal Insights manually, but I'm going to have it launch it after the trace. So I'm just going to press this button here, and I'm just going to move around and jump, and then I'm just going to stop it. Actually, I'm just going to stop the game too. And you'll see it launches this window and it automatically populates it. So you can kind of ignore this other stuff. You're not going to see tasks on yours. You're probably just going to see counters and timers. And you can, this will be checked right here. So you'll see GPU up here with all this stuff. Just uncheck that for now. So it filters that out. Over here, I've disabled the GPU tracks and some other stuff that wasn't relevant. You can reset to default to reset that. This is the stuff that's going to show up inside of this window. Right here, these are the rendered frames and stuff like that. You can just click randomly somewhere in this space. If you see spikes, that's where something caused it to take a really long time to render. And whenever you do this, you'll notice that you just see a bunch of colors. If you push forward on your mouse wheel, it'll start zooming in, and you'll realize that a lot of this is just the same stuff over and over again. So these are basically kind of like your frames. It has to execute this for every frame that it renders. And so the faster your game thread is right here at executing and processing all this information, the higher your frame rate will be. Your frame rate is going to be or hardware dependent, but the numbers inside of here will be generally like something that you'll see between different hardware settings. So they calculate these numbers so that it's somewhat independent of the hardware that you're using, but your hardware will still have an impact on these numbers to some extent. If you come over here to the timers, you can actually search for stuff. So if I search for ABP, because I know my animation blueprint is called ABP_unarmed, you'll see one that doesn't have anything next to it, and then you'll see one with _C next to it, or it might be _ something else. So those are instances, and it just puts something, it just post fixes something to it to help you identify the different instances. So if I just right click on this and highlight event, you'll see everything goes gray here, but then if you move around, you'll see something here. And if you zoom out, you'll see that it repeats because these are just game ticks. So if I double click on that, you'll see that this is the frame, and this is the tick engine, and this is the world tick right here. But then you'll have multiple world ticks here under your tick engine. These foreground workers, these are worker threads that it creates to offload processing to different threads on your CPU, so that it can offload things from the game thread. It significantly speeds up processing, and you'll see this pretty regularly. So I'm just going to highlight this stuff here, and I might have to move around a little bit. Let's see. I'm looking for, yeah, there it is. So this time, and this stuff may move. It may be on different worker threads. Every time you run this, it depends. It's just going to offload it to whatever thread is available. So in this case, what's happening here, if I come down here and I double click this, this is new to Insights. You'll see arrows, and it kind of helps you figure out where things are going, because in previous versions, you just had to figure it out on your own. So what's happening here is whenever the skin mesh component is ticked, it does some evaluation of the animation blueprint right here, but then you'll see most of it's offloaded onto this worker thread. And then after it's done, it comes up here to this complete parallel animation evaluation, and that just lets it know that it's done. It's not having to wait on it anymore. So if you double click that again, you'll see some wait for tasks. This is where the game thread didn't actually have anything to do at the time while it was waiting on this worker thread to complete its work, because the game thread does have to, it can't finish executing the game thread until these worker threads have reported back with the stuff they were tasked with. Yep, so what happens is you have your game thread, and when it gets to the point where it's, executing your character logic, it'll have some impact on your game thread. And so the more characters you have in the scene, this stuff accumulates over time. And if you multiply it by the number of characters you have in the scene, that's roughly how expensive it's going to be, which is why the more characters you have in the scene, the less performance friendly it is. Something else that has a major impact on that is your character movement component. I don't know if that'll show up here. Yeah, char move component. If I highlight that, you'll see that's right here. And that takes a lot of time right here. That is not offloaded. It does execute on your game thread, as you can see. So that's one of the big impacts on performance that characters have, as their character movement component itself. And you'll see how much more space it takes than this right here. So let me just come over to the animation blueprint, and I'll start explaining some things to you. So the anim graph on your animation blueprint, this ABP unarmed, your anim graph is executed on that worker thread. That's what you're seeing happen right here. And if you zoom in, I'll just double click off of that. You'll see different things that we're doing on the animation blueprint that do show up here. There's an F clamp here, calculate direction. Yeah, I'd have to look and see exactly where they're doing that at. But that stuff is happening on, the blueprint thread safe update event. So that was the stuff that I actually moved over here, over from the event graph over to the blueprint thread safe update animation event. And so If we come over here, let's see. Yeah, you'll see that clamp right there in the calculate direction. That's what you are actually seeing right here. Calculate direction, F clamp, that's a float clamp, and then V size XY. So I'm showing you this because offloading stuff from this event graph onto your thread safe update animation event, your blueprint thread safe update animation event will get executed on this worker thread. It will offload stuff from your game thread to that worker thread, which will help improve performance. So you'll see that right here under this animation blueprint unarmed on the game thread right here, that is doing an is valid check, which had some minuscule impact on performance. And if you come back here, that's this is valid check right here. So anything that you do right here inside of this event graph is going to execute on your game thread. It's important to understand the order of evaluation of things, because in some situations, the order of evaluation, it can cause issues, such as with, for example, trying to use, this is a naive approach, that 99.99, actually, I mean, basically anyone I've ever seen try to show people how to do hand placement using IK on animation blueprints, they've all done it wrong. I've done videos on how to do it right. And it just takes into consideration the order of operation of things, whereas those people, they just didn't consider that. And so what ends up happening is whenever you follow their video and you start aiming around real fast left to right, your hand will lag behind where it's supposed to be. And that's just because those people, they didn't understand the order of operation of things. And I'll get into that in a later video. But basically what you have to do is you have to convert that location from world space to bone space. That's basically the key. But yeah, that's basically the order of operation. You have your event graph that executes. Then you kind of like have your blueprint thread safe update animation event that executes. And then your anim graph itself gets executed. And it gets executed from the end all the way this way. So as of right now, it's executing this first. Then it's outputting that. And then that's outputting to here. And then under here, this is grabbing that cached pose. It's outputting it. That's getting outputted to the default slot. That gets outputted to the control rig, and then you get your output pose. Your output pose gets sent back. So let's see. I'll just double click that. Your output pose gets sent back over here. Skeletal mesh component complete parallel animation evaluation. That marks the end of this worker thread task. Lets the game thread know it can continue whatever else it was needing to do next. So if I unclick that, you'll see we have these wait for tasks here. These wait for tasks are basically, like I said, I think I said anyway, it's when the game thread runs out of things to do while it's waiting on your worker thread. Sometimes it'll run out for long periods of time, sometimes it won't. But either way, having it offloaded onto a worker thread, it always speeds up performance by some amount, which is why it's good to offload to worker threads when possible. So anything you can make a thread safe should be thread safe. Is valid checks cannot be thread safe. And that brings me over to this, how I converted this stuff to the worker thread. This actually has a very minuscule impact on performance, having been moved to a worker thread, but it still does improve performance ever so slightly. The thing is that you can't do is valid checks on a worker thread, which is why I'm caching that is valid check return value. And then over here on my thread safe, I'm actually only executing this logic after if that character reference is valid. And then you'll see that I have to use a property access to grab values from third parties, because you can't, if I say get this here, let's say I get this. And I get the velocity. And let's just say I promote it to local variable. If I save that, I get an error. Accessing an object reference is not thread safe, so you can't do that. What you have to do is get a property access variable node, and then you have to grab it from here. Now, sorry, I had to sneeze. I had to mute my mic for a second. So you'll see there's a slight little problem here. Is a lot of the times sometimes it may properly put this menu where it's not clipping the edge of your screen, but then at other times it's like it doesn't know, and you'll see that some of the stuff is off screen. So you might have to move it up to the top like this, just to make sure that stuff isn't like clipping, like running off the screen. But basically you can come in here. If you see an arrow next to it, that means it has things under it. It has variables or functions that you can access directly from this property access. And then you can just walk down the tree to whatever it was you needed. And then you'll see now we're getting the movement component, get movement base, get walk slope override, walkable slope angle. You see, I can remove the binding. If I come back down here and I select this one without the arrow, or if I select one under it without the arrow, it'll just stop there. So that's how I'm getting the velocity. The current acceleration is falling, because it's not thread safe to access things outside of this animation blueprint from a worker thread, because those threads are separate. They don't have access to the same data as the other thread, the game thread. And that's basically it for this video. I will see you in the next video. I'm probably not going to do another one this week. I know it was like 2 weeks since the last time I did a video, but I was a little overwhelmed by a bunch of different things. So, but I'll try to start pumping out some videos for this channel at least every week. I'll see you guys later.